Both electrics have a reputation for black magic, and the reputation is undeserved. 12-volt systems are simple. A battery wires out to loads, wires back. What makes boats different is the environment. Salt, vibration, and damp attack every connection every day. So this video is not an installation course. It is the mental model. How the battery actually behaves, why marine wire and proper crimps matter, what fuses really protect, where corrosion hides, and how to read a voltmeter like a fuel gauge. Understand these and most mysteries to solve. Think of the battery as a fuel tank that hates being empty. A lead-acid battery, flooded or AGM, lives longest when it stays above roughly half charge. Drain it flat a handful of times, and you have quietly bought a new battery. The number that matters is amp hours out versus amp hours in. Every device drawing current is emptying the tank, the engine alternator, and the shore charger fillet. If you anchor for 2 nights with a fridge running, the arithmetic decides whether the engine starts. And separate the jobs. A Stark battery delivers a violent burst for a few seconds. A deep cycle house battery delivers small current for hours. Asking one battery to do both is how you end up paddling. Charging has one rule. Over a week, what goes in must exceed what comes out. A battery kept partly discharged sulfates. The plates harden, capacity shrinks, and no charger can undo it. A modern multi-stage charger is worth its price because it charges hard, then tapers, then floats. The battery reaches genuinely full without being cooked. The old-style trickle charger does neither well. If the boat sits on a mooring without shore power, that arithmetic is exactly why small solar panels are in their heap. They replace the self-discharge and the bilge pump draw that otherwise eat the battery all week. Marine wire is tin, every strand coated so salt air cannot creep along the copper and rot it from inside the insulation. Automotive wire in a boat looks fine for a season and then fails invisibly, usually mid-strand where you cannot see it. Size matters twice over. Too thin a wire drops voltage. Your pump runs slow, your radio cuts out on transmit, and in the worst case it becomes a heater. Longer runs need thicker wire, and 12-volt systems are unforgiving about it. And every conductor should be sized for the round trip, out and back, because that is the distance the current actually travels. Connections fail before wires do. The marine standard is a proper crimp with a heat shrink terminal. The crimp makes the electrical joint. The adhesive line shrink seals it against moisture and holds it against vibration. Twisting wires together and wrapping tape is a fault waiting for a damp night. And on a boat, solder alone is controversial for a reason. It creates a hard spot that vibration can crack. Crimp first. The tool that does it properly costs less than one call out. Buy the terminals in the right sizes for your wire. The color codes exist so the crimp actually grips, and tut every joint after you make it. A crimp that pulls off in your hand aboard would have pulled off at sea. A fuse does not protect your radio. It protects the wire feeding the radio. The fuse is sized to blow before the wire overheats, which is why fuse size follows wire size, not the device on the end. Every positive wire leaving the battery should meet a fuse or breaker close to the battery. A short circuit downstream of an unfused wire turns the full fury of the battery loose in the loom, and that is how boats burn. A modern blade fuse block with a cover puts all of this in one place. Each circuit labeled, each fuse visible, spares in the lid. 10 minutes with a label maker turns future fault finding from an afternoon into a glance. Corrosion is a slow fire that eats connections from the surface inward. The symptoms are electrical, dim lights, a slow pump, a radio that resets on transmit, but the cause is chemical, and it hides at terminals, splices, and grounds. The green crust is the visible stage. The invisible stage is a thin oxide layer that adds resistance, and resistance under load makes heat and voltage drop. The connection works at rest and fails when you need it. The cure is boring maintenance. Clean terminals to bright metal, a smear of dielectric grease or corrosion inhibitor, and a yearly walk through every accessible connection with a spanner and a spray tan. Boring is what reliable looks like. A voltmeter on the house bank is a fuel gauge once you learn three numbers. Rest at no load. Above 12.7 volts is full, 12.2 is half, 12.0 is time to charge. Engine running. Mid-14s means the alternator is charging. Under load, a healthy system barely sags. Lights that dim when the pump kicks in are telling you about thin wire or a tire battery. Listen to them. One cheap digital voltmeter at the panel answers half the electrical questions a boat ever asks before a single tool comes out. So the starter kit. A proper deep-cycle house battery, a multi-stage charger, a battery switch, a covered fuse block, tin marine wire in the right gauges, heat shrink terminals with the crimper that fits them, and a voltmeter. Links to everything are in the description. Clean connections, correct sizes, fuses at the source. That is 90% of boat electrics. The rest is a multimeter and patience. Fair winds.